For 2.4, we're going to keep talking about quadrilaterals, and in 2.3 we talked about parallelograms, and now we're going to continue with rectangles. Now, rectangles is actually one of the earliest shapes we learned, way back in like kindergarten. But for the true math definition, a rectangle is a quadrilateral, 4 sides, that has all right angles. So it looks like this. Now, you guys may be thinking to yourself, why did we start with parallelogram, which is kind of a new shape for us, and then go back to rectangle, which is the easier one? Well, the reason for that is because a rectangle is also a parallelogram. I mean, if you think about it, our definition of parallelogram yesterday is that both sets of opposite sides are parallel, and that happens in a rectangle. If you look at that picture that we're looking at, because you have all right angles, these sides are parallel, and the top and bottom are also parallel. So that's why we do it in that order. We learn our theorems about parallelograms. Then when we say we're the rectangle, you say, okay, well, everything you learned about a parallelogram also works for a rectangle. But we have one new theorem. In addition to everything you learned yesterday, which means opposite sides are congruent, opposite angles are congruent, angles next to each other add up to 180, diagonals bisect each other. In addition to those 4 theorems, for a rectangle, the diagonals are also congruent. So, for our first example today, let's say this is a rectangle. I actually should have typed it into the direction. So this is rectangle ABCD. And then I gave you some information and I asked you to find something. So let's put the information in. I said BE, which is half of this diagonal, is 2x plus 10. I said CE, which is this half over here, is 5x minus 8. And I asked you guys to find BD, which is all the way from here to here. All right, well, first of all, let's figure out the relationship here. I know because it's a parallelogram that the diagonals bisect each other. So like, for example, this one is congruent to this one. Now, what's different today from yesterday is that the diagonals are also congruent themselves. So it's actually all 4 of these things that are congruent in a rectangle. And remember, that's not true for any parallelogram. The questions we did yesterday, these 2 are congruent and these 2 are congruent, but they were 2 sets of different ones. In a rectangle, all 4 are exactly the same. So I just figured out my equation. To set up my equation, this thing and this thing are equal. So I'm going to say 2x plus 10 equals 5x minus 8, and I'm going to solve for x. Let's get rid of the smaller x. I'm going to do minus 2x on both sides. That leaves just the 10 here. We have 5 minus 2 is 3x, and we still have the minus 8. If I want to solve for x, the next thing I probably want to get rid of is the 8. So I'll do a plus 8 to cancel out the minus 8. And I get an 18. Those are gone, 3x. So we divide by 3. And we solve for x. X is 6. Now, that's not the answer to the question. Remember, I didn't say solve for x. I said find BD. Now, BD is all the way. It's one of the full diagonals. What I'm going to do, I'm going to do this in 2 steps. The first thing I'm going to do is figure out what BE is. So I'm going to take that 2x plus 10, and I'm going to substitute 6 for x. We just figured out that x is 6. So I have 2 times 6 plus 10. 2 times 6 is 12, and 12 plus 10 is 22. So I found out that BE is 22, but by doing that, what I actually found out is that all of these are 22. Because remember, they're congruent. So now I can see the final answer to the question is going to be 44. Because I asked you guys to find all the way from B to D. If half of it is 22, then 22 times 2, or 22 plus 22, is 44. So your final answer to the question is 44. But remember, make sure you're answering the right question. Some people might have got x equals 6, put a box around it, moved on to the next question. Wrong answer. I didn't ask you what x is. Some people might have plugged it in, told me the answer is 22. Again, you're closer, but still wrong answer. You only went from B to E. I wanted you to go all the way from B to D. Okay, same picture. Say it's a rectangle again. This time I said if angle EBA is 65 degrees, I want you to find every other angle in the picture. Okay, so let's mark that. I gave you only one of the angles. E to B to A is right here. This is the 65-degree angle. All right, now the one I can find easily is this one right here. Because remember, this is a rectangle. That's a right angle or 90 degrees. So if I just very quickly do 90 minus 65, I get 25. So that's this angle right here, 25 degrees. Now, I can get two more pretty easily because of what we talked about using alternate interior angles. In fact, we're going to get all of them using alternate interior angles. So let's say first, I think of the top and bottom as my two parallel lines. Remember, a rectangle is a parallelogram, so you can use parallel lines. Well, if I think of that line CD over there on the right as my transversal, then, actually, no, I'm sorry, it's not CD, I'm using BD. I'm using diagonal line as my transversal. Then what you have is this is also 65 degrees. And this is also 25 degrees because those are alternate interior angles. Now, if I kind of flip my perspective and I think of these as the parallel lines, then all of a sudden, well, actually, you know what, there's one more step. Let's do this first. Let's go back to what we talked about in Module 1 when we talked about triangle inequalities. Remember how we said opposites match up? So like if you have the smallest side of a triangle, it's always opposite the smallest angle, and biggest opposite of biggest. Well, here's another use for that theorem, and a very good one. In this picture, I know that all four of these sides are congruent. We talked about it in the last example. If sides of a triangle are congruent, then their opposite angles are also the same. I mean, that's matching up. Smallest, biggest, same. So if this 65 matches up with this side, then this angle has to be exactly the same. And same thing over here. That makes this one a 65. And then for the same reason in the top and bottom triangles, you get 25 here and here. So actually you get 65s and 25s all the way around. It repeats on a rectangle. So now my last question is, what are those angles in the middle? Like, let's say I wanted to figure out what this angle right here is, right where the E is. Well, now I'm going to use the fact that triangles add up to 180. So if I look at that top triangle, I have a 25 and a 25. You add it up, you get 50. Subtract that from 180, and that'll be the blue question mark. 180 minus 50 is 130. So this angle here ends up being 130. And so does this one, because those are vertical angles and they're congruent. Now, each of the other angles, this will be our last answer, the final piece. Each of the others we can get by subtracting from 180. And 180 minus 30, or 130, brings us right back to the 50. So this is a 50, and this is a 50. So we had to remember, this was a great question because you had to remember a lot of things about angles. You had to remember triangles add up to 180. You have to realize that, subtract from 90 in the corners because they're right angles. We realize that in a rectangle, all 8 of the angles, when they're split by diagonals, end up matching pairs, 25 and 65 for all of them. And then finally, that concept about in an equilateral triangle. So remember I said because these two sides were equal, their opposite angles are also equal. That's a good one to remember too.